one of the main goals of thermodynamics is to describe the transfer of energy. So, as I saw the video, it described the two process of a transfer of energy from work and heat, and they both connected to each other. So, as a thermodynamics work, it loses heat, but when work is done on the system, it's gain heat. So heat is converted to work and work is converted to heat. Together, the work and heat transferred into out of the system represented the change in the internal energy, which, as you might recall, is the total kinetic potential energy of all molecules in the system. This idea, the change in the internal energy is the equal to the change in work plus the change in the heat. It's so fundamental that is known as the first law of thermodynamics. So we can have the equation to use for analyzing problems. We write the first law like this. Delta Q is the internal energy of a system equals Q, which is heat, minus W, which is work. If heat is transferred into the system, Q is positive. If heat is transferred out of the system, Q is negative. If work is done on the system, W is negative. If work is done by the system, W is positive. Question number 1. Calculate the change in the internal energy of a system if 400 joules of heat is added to it, and if the system performs 300 joules of work. So this is a solving of the question number 1. So what is Q and what is W in the problem? So the given is 400 joules of heat and 300 joules of work. So the W here is the 400 joules, which is the heat, and the W is 300 joules of work, which is the work as W. It's both positive, so delta U is equals to Q minus W. So delta Q equals positive 400 joules minus positive 300 joules. So the answer is 100 joules, 100 positive joules. So the internal energy of a system is 100 joules. Question number 2. Determine the change in the internal energy of a system if 500 joules of heat were removed from it and if 500 joules of work was done on the system. So let's try to solve question number 2. So what is Q and what is W in the problem? So the given are 500 joules and 800 joules. So let's see if where is the Q and W here. So Q is a positive 800 joules, while W is the positive 500 joules. So delta U is equals to Q minus W. Delta U equals 800 joules of heat minus positive 500 joules of work. So the answer is positive 300 joules. So the internal energy of a system is equals to positive 300 joules. My second topic is I will introduce the concept of calorimeter calculation involving heat and change in a temperature resulting from heat being either absorbed or lost. In order to be able to calculate the gain or the loss by acceptance, we need to know the specific heat capacity, which is given the symbol S, a lowercase, are defined as the energy needed to raise the temperature of a 1 gram of a substance by the 1 degree Celsius. Heat and temperature are not the same thing, but adding heat to a substance causes temperature to go up. And the specific heat capacity gives the relationship different substances have different specific heat capacity. The equation for calculating heat gained or lost by a substance, heat given the symbol Q is equal to the mass of a substance times the specific heat capacity times the change in temperature. So this is the equation of how to solve the calorimetry calculation. So hey guys, it's me Jordan Sattler. So thank you for watching the videos and examples about the first law of thermodynamics and calorimetry calculation. So I hope those videos are knowledgeable enough for you to be able to understand the thermodynamics and calorimetry calculation. So that's all guys. Thank you and bye.